Hello, my name is David Surushvili, and I'm a first year studying in professional bachelor's in Turiba University in the major of computer systems. And this is my semester project, which I will be presenting shortly. First, I'd like to show you the finished product, and then I'd like to delve deeper into the inner workings of the program and explain a little bit about each individual cog. So, let's get started. First, we should start a new server socket that all the other clients will connect to. This is the part where we are going to initiate a new socket on the port 3001 and click start. So after you successfully do this, you should get a message that displays your current IP and your port. Next, what you should do is go and connect each individual client of yours to this newly initiated server, and we're just going to do that just now. Just input your credentials and the port. It should not take you more than a few minutes. Once you successfully connect to the newly created server, you should get the message that says you are connected and you're waiting for others. Let's quickly connect these other two up. There we go. And as you can now see, all three clients have connected and the game is started. The paddles are different colors to indicate the different users, and they are going to be switched every 30 seconds for additional fun purposes. And as you can see, the controls of each paddle and ball are synced. In the top right corner, you will see the score keeps tracked by the ID of the user. And once all the balls are destroyed, you are going to get an appropriate message that says you won or you lost. So if you win, you're gonna get a congratulations, you won. If you didn't, well, you can always try next time. It seems very simple at first from the functionality that I just displayed, but there's some parts of this that can get quite complex. But I won't explain all the details because I don't want to bore you. But I would like to give you a little bit of an understanding of what's happening inside. So, let's first start by examining the server. As you can see, we first start in the main class, where we first do initialize the UI with all the swing elements. I use the Java Swing framework in this case just to quickly create a mock-up of all the inputs and text fields I needed. But this is not an important part of the functionality, so I'll just quickly skim over this. We create a new panel, we set its colors and sizes, and then we quickly create a new layout to which we add our elements to the according x and y coordinates and set their visibility. And once that's all done and port has been entered and the start button has been clicked, this function will trigger and it will create a new server class, and it will give to the constructor the inputted port and the main IP which we calculate right here. Let's see what server does. Once the port and the string host has been given to the constructor of this server, the server will try to initiate a new server socket with the given port and with the IP that it was given. If not, it will throw you a runtime exception. But if everything goes well and this starts, then your server has been successfully started. Now let's see what happens during the start of this thing. So we are going to start by running sort of a game loop, which is more appropriate to say it's a server loop, which will constantly accept the incoming sockets to this socket we just initiated there. But for the sake of this game, I have a prefixed limiter set to 3, so the only type of there can only be 3 connections at one time in this game. But if this condition is satisfied, we initiate the socket by creating a new connection class and giving it an ID and putting it in our dictionary of connections and creating a new packet to inform the connection that just connected to us that hey, you're connected, and start a new thread. Connection class contains the socket of the connection, or more rather to say client, and the input stream of the socket and the output stream of the socket, and all the events incoming from the connection, from this particular connection. As you can see in the constructor of this class, we define all the necessary output streams and input streams to get information from the socket, as well as attach an ID to ourselves. And we run another connection loop here to be constantly receiving input from our clients. This is a very useful function to write whenever writing something like this, because it handles all the necessary operations to be able to send information to the client. Now, all the main logic of the server happens in the event listener. Event listener gets to receive every event that clients send, and it does so by listening if the incoming packet is of a particular class or not, and then it does the logic accordingly. For example, if it's an add connection packet, inform all the other clients that the new client has joined. If someone leaves, inform everyone else that they left, and so on and so on. It has all the other necessary packets like this. Now, let's look at the client now. Clients also start by initializing the UI first in the exact same manner as the server. We start by initializing the main panel, setting its color, setting its size, and setting its visibility. Then initiating the layout and adding elements of UI such as IP input and port input and the join button to this layout, and all the other necessary X and Y coordinates to each element. This is used to validate if the IP address that the user inputs is valid or not. Now, when the join button is clicked, it will call this function, and it's going to validate the user inputs to see if the IP is not null and port is valid, then you can connect. If not, then you need to display an appropriate error message. However, if it connects, a new client class will be initiated, which runs on the exact same logic as the server. We have our event listener, we have our socket, which the connection uses, we have our host of the host, which is the IP of the server, and the port which the user inputted to connect to the server. Next, when you connect to a server, you create a new socket, and so starts the listening for the new events. Event listener operates in the exact same manner as the server listener. It listens to the incoming packets from the server and displays logic accordingly. For example, if the particular packet is an add connection packet, this means that a new connection has joined the server, and to update our local database of new connections, aka players in our case. The board class is where the main action happens. In the board class, when we initiate a new class, we start to attach the key listeners, which allow us to move the paddle using A and D buttons, and set all the other necessary parameters for it to work, such as the border size, if it is focusable or not, and how big the window should be. Update state function gets called every time information is synced between the server and the client. It handles all the necessary things such as paddle movement, the ball coordinates, and the number of bricks that are left. Paint component draws all the necessary assets such as the ball and the paddles and blocks, of course. And if the game is finished, this function will get called, and it will check if the winner is the ID of the client. That means that client has won, and it will generate an appropriate message and display it on the center of the screen. Per game cycle, we do the following things. We move the ball and we move the paddle. Keep in mind, this is an important detail. We move the paddle with the lowercase p. This means that the paddle that the client controls, not all the other paddles that are displayed. All the other paddles that are displayed are moved using this for loop, which cycles over the server given information of the paddle's coordinates and sets them appropriately. Then we need to check if the ball is colliding with anything, such as a block or a paddle, and change the direction of the ball and update the score count and repaint so that the user can see the new position of the assets and instances of objects. In conclusion, I think this works as a good base plate for further developing this type of application. Of course, you can always polish it more and add some new features, such as maybe sounds or other graphics. But I would say that the main functional logic part of this application would be done. Um, and I guess I'll sign off now. Thank you for your attention.